All right, so we're going to talk about how to graph quadratics, which means you're going to need some graph paper. And we're going to talk about how some of the differences in the quadratic function can cause differences in the graph. So the main graph that we're going to be comparing everything to, like our baseline graph, is called the quadratic parent function. And it is the most basic of quadratic functions. The most basic function, the parent function, is f of x equals x squared. And we're going to do some experimentation with this function. We're going to see what happens when we add or subtract various numbers into this function. So for example, we're going to start off by comparing the parent function, f of x equals x squared, to this function. We'll call it g of x. G of x equals x squared plus 6. So the question that we want to answer here is, what happens to the parent function when you add 6 onto the end? What does that change about the way the parent function looks? So of course the first question that we need to answer is, what's the parent function look like? So later on I'm going to show you how to graph these without making a table, but for now we're going to start off making the table. We haven't made an XY table in a long time, not since we graphed linear functions. And we're just going to pick a handful of x's. It doesn't really matter what you pick to plug in, but I'm looking for really a couple of things when I find x's to plug into the function. I'm looking for numbers that are small, because small numbers, number one, are easier to do math on, and number two, will fit on a graph. And then the other thing I'm looking for is, I want a mixture of positives and negatives. So I'm going to go ahead and pick 5 numbers, and these are pretty common numbers to use. I'm going to do -2, -1, 0, 1, and 2. So I get a couple of negatives, I get a couple of positives, and 0. Okay. So I wrote y, which is kind of a mistake. Really, I should have written f of x. That would have been a smarter thing for me to write, because I'm using the f of x function. And the f of x function just says take the x's and square it, so let's do that. If I take -2 and I square it, what do I get? It's -2 squared. 4. -2 times -2 is +4. Okay, what if x was -1? What's -1 squared? 1, good. What's 0 squared? 0. I thought you said 2. I was about to come across this table. What's 1 squared? 1. And what's 2 squared? Now what you can tell from the table is that this graph starts at 4, drops down to 0, and then comes back up to 4. So that means what this graph is going to do is it's going to start up high, it's going to dip down, and then turn around and go back the other direction. It's going to make sort of a horseshoe shape. So go ahead and take out one of your graphs that I gave you. And I am going to plot these points that we've got right here. I'm going to start off with the point -2, 4. So I'm going to go -2, +4, right there. Okay, then we'll do -1, 1, 0, 0, then 1, 1, and then 2, 4. And I'm just going to go ahead and connect these. And just like we expected, it goes down and comes back up and makes this horseshoe-shaped figure there. Okay, so let's do the same thing, only with our x squared plus 6. So I'm going to go back to this table here, and I'm going to make another column next to the f of x column called the g of x column. Now let's take a look at what the g of x function does. What the g of x function says is take x squared and add 6 to it. So I'm going to take the x squared column, which is this one right here, and add 6 to it. In other words, x squared was 4, so x squared plus 6 would be 10. X squared was 1, so x squared plus 6 will be 7. X squared was 0, so this will be 6, and then
7,
and then
10.
So this one does the exact same thing that the first one did. It starts at 10, drops down and comes back up to 10, only where the first one, x squared, stopped at 0 and came back up, this one stops at 6 and comes back up. Okay, so I'm going to go back to my graph paper. I'm going to graph that on there. So 410, negative 210. That one. And negative 17. Then 0, 6. Positive 17. And positive 210. Notice I'm using the same x's, negative 2 to positive 2, but the new y's. This one also makes a horseshoe shape, but it's a little different. What's different about it? It's higher. How much higher is it? How much higher is the second graph than the first graph?
6.
It's 6 higher. So adding 6 onto the end of the function does what? It raises it 6 units. That right there raises the graph 6 units. If you want to impress people with your math vocabulary, the phrase that you would say is translates up 6 units. If you were like on a date with somebody and it was going really well and you were like, what can I say to impress them so I get a second date? Translate up 6 units would probably do the trick. Full disclosure, I don't go on a lot of dates, but I feel like that would work on me, so probably work on everybody. You think? Who's with me? Translate up 6 units? No? All right. Well, clearly, at least one of us does not understand what it takes to have a successful date. Cool. That makes sense?
Not really, but I'll roll with it.
Okay, great. Do you understand x squared?
Yes.
So x squared plus 6 takes that x squared. It's called a parabola. That's the shape.
It's called what?
A parabola. That's the name of the shape. Parabola is that horseshoe shape. So it takes that shape, the green one was the original one, and it just slides the whole thing 6 units up. That's what the plus 6 does to the graph. Okay, let's do another comparison. This time, let's compare those two. Now, before we do anything, just take a guess. What do you suppose f of x is going to look like compared to g of x? What's the difference going to be?
One's going to be above
Which one's going to be higher?
the 3.
Yeah, the plus 3. What's going to happen to the minus 5?
This is going to be lower.
Right.
On the bottom.
So this one's going to take the parent function x squared and drop it down 5 units. And this one's going to take the parent function of x squared and raise it up 3 units. So how far apart will these two parabolas be?
2.
2?
No, because it's a negative 5 to a 3. It's going to be
8. They're going to be 8 units apart. Okay, so let's go ahead and make our table.
Oh, the 3 up from 0, not 3.
Right.
Okay.
And we'll do our numbers here again. Negative 2, negative 1, 0, 1, 2. So let's do f of x. See if you can do this without writing it down. We're squaring the x and subtracting 5. So negative 2 squared is 4 minus 5 is, there we go. Okay, if x was negative 1, I would have negative 1 squared, which is,
1.
and 1 minus 5 is,
Negative 4.
there we go. Next would be 0. 0 squared is minus 5. Good.
5.
1 squared
1.
minus 5.
Negative 1.
2 squared.
Negative 1.
2 squared is negative 1. Are you trying to hurt me?
4.
The answer is negative 1.
Yes,
4 minus 5
negative
negative 1.
1.
Okay.
I didn't know where she was getting.
Right.
Okay, so I'm going to go ahead and graph that one on here. My points would be -2, -1, -1, -4, 0, -5, 1, -4, and 2, -1. And there it is. Okay, let's go ahead and graph the g of x function then. So back to our table. Let's make a new column for g of x. G of x is x squared plus 3. Okay, so my first x was -2, so it's -2 squared, which is
4.
4 plus 3 is
7.
okay.
I haven't written it down yet.
If x is -1, I have -1 squared, which is
1.
plus 3.
4.
There we go. 0 squared is
0.
plus 3.
3.
1 squared
1.
plus 3.
4.
Good. And 2 squared
4.
plus 3.
7.
There we go. And so now on the same graph, we're going to put the first coordinates -2, 7. Then -1, 4. Then 0, 3. +1, 4. And +2, 7. Now our expectation was that these graphs would be 8 units apart, and we could see if we were right by counting maybe this middle point. 1, 2, 3, 4, 5, 6, 7, 8. The second one actually is 8 higher than the first one, which is what we expected. We expected it to be 8 higher. The -5 and the +3. What was that?
Your dot's low. Your dot's likely different than what mine is. Where you graphed it. -1 up 4. Okay.
It's probably because I have aggressive alpha dots that a real man would draw, and you're a tiny little woman, so
We'll roll with that one.
that's got to be the
We'll tell
difference.
them the truth.
It's got to be the difference. If you'd like me to help you draw your dots, be happy to do that. As a man, I have dot experience.
A, B. There we go.
I know, for some reason, getting the first one down, the negatives are throwing me off. I can just look at them all over the place.
The graphs always throw me off. It's just trying to, I'm just not a dot kind of girl.
All right, fair enough. Okay, so that's what happens when you add or subtract a number onto the end. If you subtract a number, it drops down, and if you add a number, it moves up from the position of the parent function, which was x squared. Okay, so let's investigate a new relationship. It's always exciting when you have a new relationship. We're going to investigate the parent function, x squared, as compared to this function,
Is this always the parent function?
x squared is always the parent function. The parent function is like the most basic version of the function. X squared is the most basic, because to be a quadratic, it has to have x squared. So the most basic quadratic you could have would just be x squared. That's why it's called the parent function. Although I did have a math teacher one time that called it the mother function. The mother function. But parent function, I think, is the acceptable name for obvious reasons.
Mm-hmm.
So let's go ahead and make our table. Oh my gosh, that is so rude.
I'm so sorry.
If I had feelings, they would be hurt. Okay, so I'm going to go ahead and do the parent function first, and I'm not actually going to do the math again because I did the parent function on this first page here. So I'm just going to copy those values straight over. It was 4, 1, 0, 1, 4. No reason for me to do the math again. It's the same every time. Okay, so I'm going to go ahead and take the graph and put the parent function on there. So, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And there's my parent function, just like before. So consistent.
If I could draw my lines between the dots too.
So what happened on these first problems here is that adding or subtracting changed the y value. The y values from the parent function were changed in the new function. Same thing down here. The y values are changed by adding and subtracting numbers on the end. When you have numbers that are added or subtracted inside the parentheses being squared with the x, what changes is the x values. The x values are different. Okay? It's going to become relevant to us in just a second whenever we make our second table. Let's do g of x here. So what we're going to do with g of x is we're going to add or subtract the number first and then square it. Okay, so you do negative 2 plus 6, which is 4, and then square it. Okay. Then we do negative 1. Negative 1 plus 6 is, and 5 squared. 0 plus 6 squared.
36.
1 plus 6
6. Oh, 7.
squared.
49.
2 plus 6.
12.
Why do you hurt me?
2 plus 6 is 8.
Squared.
64.
Okay. So I see a little bit of a problem with that second column. Do you see what the problem is?
They're not consistent like the other ones.
Well, you can't go that high.
First of all, my graph is not that big. That's not the only major problem, though. What has every other graph done so far? Yeah, you're making the hand motion. It has started high, come down low, and then gone back up. It's made a parabola. Is g of x going to do that with the points that I have graphed?
No.
No, it's just going up. What that tells me is somewhere on the other side of negative 2, like if I could extend the table this direction, it would turn around somewhere up here. Does that make sense? Like the turnaround spot is off the table. So I need some numbers lower than negative 2. So I'm going to come over here and make a different table for g of x. Negative 2 is where, negative 2 is where I ended here. So I'm going to do like negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. I don't know if I'm going to need all those, but I'm going to try some more until I get to the spot where it turns around. That's what I'm looking for. Where does it turn around? Okay, so let's do negative 3. Negative 3 plus 6?
3.
Squared?
9.
Okay. Negative 4 plus 6?
2.
Squared?
4.
Good. Negative 5 plus 6?
1.
Squared?
1.
Negative 6 plus 6?
0.
Squared?
0.
Negative 7 plus 6?
1.
Negative 1.
Negative 1.
And negative 1 squared?
1.
Negative 8 plus 6?
2. Negative 2.
Negative 2 squared is?
4.
Does this show me the spot where it turns around?
Mm-hmm.
Yes, it does. Where's the lowest point?
0.
0. So I'm going to graph like maybe these points. That tells me the important part. It tells me it comes down to 0 and then turns around and goes back up. So I'm not going to graph all these points. I'm just going to graph the spot where it turns around. So that means my coordinates are going to be negative 8, 4. Negative 7, 1. Negative 6, 0. Negative 5, 1. And negative 4, 4. Okay, so let's answer the important question. What did the plus 6 do? Moved it to the left. So this right here shifted the graph, shifted the parent function left. Shifted it left. What do you suppose would happen if that had been an x minus 6? Oh my gosh, what a good observation. Probably would have shifted it to the right. How about that? Well, let's find out if you are correct.
Mine so much further over than yours.
Because I'm very good at counting.
Oh.
I can give you some counting tips later if you want. Now, before we do anything at all, if you had to guess, what would your guess be for what these numbers are going to do? Recall that the parent function is x squared. What's different about this compared to the parent function? Well, the minus 3 is new, and the plus 1 is new. If you had to guess, what would you say the minus 3 is going to do? To the left 3?
To the right.
Plus 6 moved it to the left.
Negative square.
That should, okay, so we're thinking this is right 3 units. And what do you think the plus 1's going to do?
Add one more.
To what though? How's it going to move?
4.
What happens when you add or subtract a number and it's not in the parentheses? Moves it up or down. So what's the plus 1 going to do? Up 1. So up 1 unit. Numbers in the parentheses move it left and right. Numbers out of the parentheses move it up and down. Okay, so let's see what this looks like. Again, I'm going to start with the parent function as a point of comparison. Nope, those are just their names. We called one F and one G. F's our favorite. Now I know if I do -2, -1, 0, 1, 2, it's probably not going to include the spot where it turns around, just like on this one. Using the same points did not include the turnaround point. What did include the turnaround point? Well, the turnaround point was when x was -6. Is there a way that we could have been able to tell just from the equation that -6 was going to be our winner? Because -6 plus 6 gave us the 0. Is this one's lowest point going to be 0 though? Plus 1, so what's the lowest point here going to be? It's going to be 1, right? Like without this, the lowest point would be 0. But I moved it up 1, so the lowest point's going to be 1. All right? So what x value would give me 1? Well, what x would I have to put there so that this whole thing equaled 1? Well, that'd give me 2. I'd have 4 minus 3 squared, which is 1 squared, plus 1. That'd be 2. 3. So 3 is going to be my turnaround point. So when I make my table to graph this new one, 3 is going to be the point in the middle. that's where it turns around. And then I'll just go up 2 and down 2. I mean, up on the table, down on the table, not bigger and smaller.
So that's supposed to be an fx on the right and not a gx?
Right, f of x was this guy.
Okay.
G of x was the parent function.
Oh, okay.
I mixed them up just to ruin your life. Is it working?
Yeah.
Sweet. All right, cool. So I already know what 3 is going to be. That's going to be 1. Right, you just told me. 3 minus 3 squared plus 1 is 1. Let's do the rest of them. What's 1 minus 3 squared?
8. Negative 8.
Okay, let's try again. What's 1 minus 3?
Negative 2.
And negative 2 squared is?
4.
And 4 plus 1 is?
5.
What about 2? What's 2 minus 3?
Negative 1.
And negative 1 squared is?
1.
And 1 plus 1 is?
2.
All right. Okay, what about 4?
1.
Yep. Oh, no, sorry, not 1. 1 plus 1.
2.
And what about 5?
5 minus 3 is 2, and 2 squared is 4. Plus 1 is 5.
Hey, look. We kind of could have predicted that, right? We knew 1 was the middle, so it goes down to 1 and then it comes back up. Same numbers, right?
No. The one got the 1 and 5, the bottom is the 5.
Okay, let's graph them. Let's start off with the parent function, our buddy. And then we'll do our weirdo function. So it's going to be 1, 5, 2, 2,
Oh.
3, 1, 4, 2, and 5, 5. So our hypothesis when we started this is that it was going to move it 3 to the right and up 1. Were we correct? Did the parent function go 3 to the right and up 1? Looks like it did. I think we nailed it. And by we, I mean me. I'm awesome. High five. Nope, nobody? Okay.
No.
Okay, that's fine. I'll high five myself.
I need that lowered again, please.
Hold on, I'm working on it. I'm taping my graph down here.
Oh, there it is.
Calm down. Stop making demands, woman. I'm just one man. I'm doing the best I can.
Oh, I thought you were going to move forward.
No one likes a smart aleck the week before finals, young lady. Be polite. Okay, so we have put a number on the end. We put a number inside the parentheses. Where else could we put a number?
As a fraction.
Oh yeah, fractions are coming. But there's one spot on the parent function we have not put a number. How about in front? We have not put a number in the front.
Well, if you look at this one, they could be both. This could be the front.
So we're going to graph our parent function. We'll call him f.
Okay.
Call him f in honor of your final exam grade after all the abuse you've given me today. Then we'll do g of x. Do that 3x squared. And let's go ahead and toss another one in there. Let's do h of x. You said you wanted fractions. Who am I to deny you?
No.
No, we didn't.
Who am I to deny you fractions? Okay, I'm going to try to be consistent with my colors here because we got so much going on. Now, the good news on these is that there's a number in front. We are not shifting them up and down, and we are not shifting them left and right, so they're all going to have the same bottom point. Like they're all going to turn around at the same spot. So we'll do f of x first, because that one's easy. We've done it so many times, you should almost have it memorized by now. There's our main dude, the parent function. Okay, so 3x squared means take the x squared thing and multiply it by 3. So the x squared was 4. If I then triple that, I get 12. 1 tripled is
3.
okay, 0 tripled is
0.
and then
3.
starts to come back up. 3.
12.
Good. All right. Let's go ahead and put your boy h on there while we're at it.
3.
That means take the x squared and multiply it by a fourth, which is the same thing as dividing by 4. So take the parent function, x squared, and divide all of them by 4. So 4 divided by 4?
1.
1. 1 divided by 4?
Quarter.
A fourth. 0 divided by 4?
0.
1 divided by 4?
A quarter.
4 divided by 4?
1.
Okay. So on our graph, we'll start off by graphing our parent function first. Our old standby, the parent function. And let's see if we can figure out what the 3 does to that g of x. What problems does the 3 cause? So first of all, my first point is negative 212, which I don't even think will fit on this graph. 7, 8, 9, 10. Oh, it's at the very top. Yeah. I knew we could do it. I never doubted it for a minute. Next will be negative 1, 3. Then 0, 0. Then positive 1, 3. Then positive 2, 12. Okay, what did the 3 do?
Disappeared.
The 3 disappeared. No, that's what did the 3 make the graph do?
Yeah.
It's narrower. I squished it. It's like I grabbed it from both sides and jammed it together. So before we graph it, what's your guess for what the 1/4 is going to do? It's probably going to make it wider. I think that's a reasonable guess. Let's find out. So negative 2, 1 is the first point. 1 and 1/4 we'll have to estimate. There's 0, 0. Positive 1 and 1/4. And then 2, 1. And indeed, that is a wider graph. It's kind of a cute little face we made, isn't it? So this is wider. Well, I just can't think of anything else we could possibly do to these. We put one inside, we put one outside, and we put one in the front. Got numbers in the back. I just can't think of anything else we could do besides those. I mean, can you think of anything else?
Nope. Not at all.
I sure can't.
Liar.
No, you didn't.
Oh, we haven't done negative. That is such a good suggestion. We haven't done negatives yet. Yeah, outstanding. Okay. What do you think a negative is going to do?
Oh.
Okay, you know what? You're right, but
Upside down.
it's going to flip it. That's what you do when a problem comes along. You must flip it.
With it, not flip it.
I don't know what you were doing in the 80s, but I was learning the lyrics to that song. And I'm pretty sure it's about math. When a problem comes along, you must flip it. You guys are so funny. So fun. Lots of attitude the week of finals. You guys are brave people. So x squared, negative 2 squared is 4, and 4 times negative 2.
Oh, I did it without my little number thing.
Without your little number thing, it's called a calculator. Jeez. If you don't know the name of it, you can't use it. Negative 1 squared is
1.
times negative 2. Good. 0 squared
0.
times negative 2.
Negative 2.
0 times negative 2 is negative
0.
2. 1 squared times negative 2. And 2 squared times negative 2. All right. Let's put it on there. So negative 2, negative 8. Negative 1, negative 2. 0, 0. Positive 1, negative 2. And positive 2, negative 8. All right, who had it flips it upside down in the pool? Correct. This one actually flips, and it's got the 2 in front, so not only does it flip, it... Is that what the 2 in front does? Shifts
No,
it?
it's narrow.
It's narrower. Good. So it's narrower than the parent function, and also it's upside down.
There's a spider.
Spider where? Where?
Right there.
Oh, he's cute.
I'm gonna squish it.
Oh, don't squish it.
I'm gonna squish it.
No!
Why?
Leave the spider. What is he? He's not even bothering you.
He comes over here and does like on him.
Oh my gosh. Fine, I'll save Charlotte.
Well, I'm Wilbur.
I don't like spiders.
Oh, it's hurt too. It's only got like 6 legs.
Oh, you're so friendly.
Sounds like, yeah, see, the main thing would be to stop it.
Oh,
Somebody must fix it. Ew.
Okay, the spider doesn't want to be saved.
He died.
No, oh, there we go. Okay, hold on, buddy. All right, nobody panic. We're releasing
I want to
him
see him
alive.
do that to a brown recluse.
As in the wild, you mean down the hall.
Outside.
Me too.
I'm just throwing in the trash.
I would have just squished him right there. Like my neighbor.
He's like, and this spider will be somebody else's problem. Go into another classroom.
1, 2, 3, 4, 5, 6, 7, 8. Oh, 2. I hate this
I can't believe you wanted to murder that spider. What is wrong with you people? Spiders eat pests.
thing. Well, you're still here.
they don't eat all the pests.
They don't eat scorpions, so.
They don't?
I don't think so.
Only one way to find out. Next week, somebody bring a spider and a scorpion, and we'll have them fight to the death.
We won't be here next week. You gave us a week.
Oh, right, that's I forgot. That's just something I told you.
That, though.
That's just something I told you so we could get a break. Okay, let's put them all together.
What the heck?
Nah, you're fine. Go whining. Okay, so before we actually graph this, let's make a prediction. What is going to happen to this graph compared to the parent function? What is the 1/2 going to do?
Still
This is going to make it wider.
This is gonna make it be up.
Is it gonna be flipped?
No.
No, because there's no negative. So one of the ways that you can say this is that it opens up. Opens up means it looks like that.
Wider.
Because it's not a negative. Okay. What's the plus 2 gonna do?
Take it up to.
To the left.
Oh, no.
2 units.
Shift left 2 units. And finally, what will the 5 do? That's what makes good.
Go
Good.
up.
That's what makes it go up. Shift up 5 units. Great. So that's our prediction. Let's see if we're right. So when you're doing one of these tables, just take a minute and think about the x's you want to use for the tables. Don't just start going like -2, -1, 0, 1, 2. Our table needs to include the spot where it turns around, and you learned just a few minutes ago how to find that spot. The spot where it turns around is the place where the inside of the parentheses equals 0. So what would x have to be so that the parentheses equaled 0?
-2.
So -2 is where it's going to turn around. That's going to be my middle point. And then I will go up a little bit, -1 and 0, and I'll go down a little bit, -3, -4, and that'll give me 5 really good points to use. I'm sorry to say the math here is going to be a little heavy duty because I don't think we're going to be able to do this one in our heads. I think we're going to have to write this one down, substituting it in. So the first one, -4, I'm going to do g of -4 is going to be 1/2 -4 plus 2 squared plus 5. What's -4 plus 2?
2.
-2.
-2.
-2 squared is,
4.
so this is going to be 1/2 times 4 plus 5. What's half of 4?
2.
Plus 5?
7.
So -4, 7 is our first coordinate. Okay, let's do -3. G of -3. So 1/2 -3 plus 2 squared plus 5. -3 plus 2 is
-1.
squared.
1.
So this is 1/2 times 1 plus 5. What's half of 1?
Half.
Plus 5?
1/2.
So 5 1/2.
You would use 5.5, not 5.5.
It doesn't matter. You can use whatever. If you prefer decimals, be my guest. Okay, next on our list is -2. So 1/2 -2 plus 2 squared plus 5. -2 plus 2 is
0.
0 squared.
0.
So half of 0 plus 5. Half of 0 is
0.
plus 5 is. And because we know that -2 is the spot where it turns around, I don't have to do any math to find -1 and 0. What are -1 and 0 going to be?
5.5 and 7.
5.5 and 7. Once it hits the bottom, it turns around and goes back up, and we already figured out -2 was the bottom. Okay, so on to the graph we go. So my first point was -4, 7. Then -3, 5.5. Then -2, 5. Then -1, 5.5. And then 0, 7. And there it is. Wider, opening up. Left 2, up 5 from the parent function. And that one's pretty much the worst that they get as far as graphing is concerned. It's a lot of arithmetic. It's a lot of plugging in numbers to find out what the answer is, but if you can handle that part, you'll be okay. And if you can't handle that part, what are you even doing in this class? That's adding and subtracting. I mean, you can do it. Have faith in me. Any questions about those?